welcome back to the Hakian channel. So today we are going to be doing using congruence in proof. So this is followed by exercise 7D because you now have been able to identify the 4 different types of ways to describe congruency of triangles. So today it's more so how you use your identification of triangles and proving your steps that you use to identify what kind of identity the triangles have. So today's learning intention is to know the working out and correct notation to prove congruency. So I'm going to go through the steps with you so that it's very clear what we expect. Today's success criteria is that you can use congruency abbreviations, which is from the last exercise. So that's right hand side, 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 angle, angle, side, or side, angle, side. Okay, you need to be able to write your working out using a specific order to match, the selected congruency proof that you've chosen. And you need to be able to provide reasons at each step. So not just saying, yes, it is that. You need to say, this is congruent because this also shows that it's equal. So worked example 1. So the question says prove that this is triangle. That's why it's a triangle. So when I read that, okay, it actually says triangle ABC. Prove that triangle ABC is congruent. That's what the 3 lines is. It's not an equal sign. Don't get confused. So prove that triangle ABC is congruent to triangle ADC. So you're probably looking at this and wondering, I don't really, might not be able to read and identify that. So the first thing is I'm just going to use green just to show how we would read that on the triangle. So triangle ABC would be starting from A, because it starts from A, then B, and then C. That's how I would read that one there. The next one, which I'm going to do in blue for you, triangle ADC, is triangle ADC. Okay, and that's how you would read it and follow on. So with that said, okay, so to prove, if the question is asking you to show congruency proof for the triangles, you can start off by saying, in a triangle ABC and triangle ADC, I've just copied that and just put that there. Yep. Okay, we can see that firstly, there is what angle there. So there's 4 that you can choose from, okay? So you've got side, angle, side, you've got angle, angle, side, you've got right-hand side, or you've got, I've just gone side, side, side. Just had a massive mind blank there. So the first thing is, what can I see that's very obvious about the triangle? And I can tell you that the first thing I notice is that they both actually have right angles. So I already know that the one I'm proving today is right hand side. That's what I'm doing. So what you can do is you could say this symbol here means angle. Okay, it's not a triangle. So we need to be able to remember triangle is a triangle and angle is like a little like, you know how you do those like little emojis? Okay, that's what it is. So angle ABC equals angle ADC, and that is 90 degrees. So we can just prove that. So the order matters. What you write in order matters. Okay, so you must know that. Do you see what letter does the right angle sit on here? It sits on B. What letter does this stand on? D. So that means B and D has to be the middle letter when I write it. See how B and D are the middle letters? That's the angle you're looking at. Now you might be curious and you might be saying, why can't I do angle CDA and angle CBA? So rather than doing it starting from A and going this way, like I did with the green and blue arrows, why can't you do it the other way? Well, actually, you can. But for this example, I'm just using ABC. As long as the middle number was as long as the middle letter is the letter that has 90 degrees, that is what we're looking for. All right? So that's the first thing, proving the angle. We're going to be practicing it. AC is common, okay, for the H. So we see AC. AC is the middle line right here. They both share this line. So you can just simply say AC, like the line AC is common. That's it, okay? So you should write you know, what they are as you go, so you know that you're crossing off the proof. So the last thing we're looking for is S, which is a side. So AB equals AD. AB equals AD. And usually the side we pick is the ones that have a line on them already. So we can see here that it's been marked right there. So AB right here equals AD. Okay. You wouldn't say AB is equal to DA. You must read them and write them the same way. So if I started from A for the first one, like AB, then I have to start from A from the next one. So if you wanted to do DA is equal to BA, okay, that would still be accepted because that is still reading from the outside to the A, outside to the A, okay? But this is just one example. So after you have proven your congruency pattern, then you can say, therefore, triangle ABC is congruent to triangle ADC. And you can say what you use to prove that. So let's do another one. All right, so prove that triangle ABC, so I'll just write it again so that you know. Triangle ABC is congruent to triangle EDC. Okay, so if I had to show you again, let's do this again. So ABC, so ABC, so A to B and then C. That's how I'm reading it. And the next one in blue, EDC, triangle EDC, E, D, and then C. That's how I'm reading. Do we see how it's like literally mirrored image? That's what you want. So the first thing is, out of the 4 choices we have, which one is it? Well, I can see that there's angles and sides. Now, even if you get it wrong, you can always erase and go back if you figure out that you can't use it. So in red, all right, I've written angle ABC, angle A, B, and C. So what angle are we looking for? We're looking at B and we're looking at C. So I'm looking at B and I'm looking at C. Okay? Angle B and C, ECD. And they are vertically opposite angles, B and C. So we know that that's already going to be an A for angle. And that's from exercise 7B, okay? Angle ABC is equal to EDC. So now we're doing this angle here. So that one there and this one here, they are alternate angles because they have parallel lines, all right? So that's an angle A there. So the last one, BC, this is now a line. When you do sides, it's always 2 letters. So BC, we're looking at which one has the symbol, the like little line on the line. So there, that one. So BC equals DC. BC equals DC. I did not say DC equals CB. So I went from BC that way and I went DC that way to do this one here. And your last step is to just finally say your answer. So therefore, triangle ABC is congruent to triangle EDC. And we used AAS for angle, side. All right. Now, this one has a part A and B. So let's have a look. Prove that triangle ABC is congruent to triangle EDC. So let's show the way that I've done that again. So ABC, all right, and EDC, which is EDC. So in the end, they all go to C. So let's do A first. So I can see there's 2 sides already because I can see that there's a single line here, a single line there. That's one side. I'm trying to find my pencil. I can see there's a line there and 2 lines there. So that's the second side. All right. And, you know, I'd probably pick the angle that they have in common between those 2 lines. All right. So the more you see on your triangles, the most likely you need to use that, what you see, to prove your congruency. So triangle ABC here, okay, and triangle EDC over here shows what? AC and EC are equal. So we're saying AC down here, and EC down here equal. So that would be in red. All right. BC equals DC. So let me just do that in purple. BC equals DC. DC. And that would be there. All right. Now, angle ACB equals angle ECD. So which angle are we looking at? We're looking at C. They both have C. So we're looking at angle ACB, so C. Remember, the middle letter is what you're looking for. And I might just erase all of that so you can just get a feel of what we're doing. So ACB and ECD. So we're looking at this one still. Oh. So we're looking at the same angle there. So that is vertically opposite angles, which we know from exercise 7b. So triangle ABC is congruent to triangle EDC via SAS. Even though you're working out what's SSA or, you know, ASA, doesn't mean you can't write it as, doesn't mean your working out has to align with what you wrote down here, okay? But just make sure that what you write down here is the 4 that we start with, all right? It's just easier that way that you keep your letters consistent when you write it. So for B, it says, hence prove that AB is parallel to DE. That's why it's got parallel lines. So that one there, which I'll do in, oh, that's not a very good color. Okay, that means parallel. So we could say that because angle BAC equals DEC, okay, therefore AB is parallel to DE. So angle BAC, we're looking at A and we're looking at angle E. So let's find it. BAC, that's this one here. Okay, I'll just do star there. And angle DEC, so that's this one here. All right, so I'll just get rid of that. So looking at these two there, all right, and they match. So therefore, the alternate angles are equal, and so we can say AB would equal DE. All right, this is the last one. I know it's getting quite complicated, and your brain might be needing a bit of a break. Just one more. So it says prove that triangle ABC is congruent to triangle ADC. So let's do that. ABC, which would be this way. That's this one. And the last one would be ADC, which is this way. Okay, see how I always start from A and I went this way and this way. Okay, so you got to prove, no, sorry, we're still doing the first one. So in triangle ABC and triangle ADC, all right, we can see that there's two sides for starters. So these two are the same, these two are the same, and I can actually tell these two would be the same because the lines that are connected to that angle are the same. So we can say AB equals AD. So let me just erase all of that for you. Okay, and use the colors that I've done. So AB, this one here, is equal to AD. Okay, it's not AB equals to DA, it's AB equals to AD. BC equals to DB. DC. Okay, that's given to you there. Now, AC is common to both triangles. Remember, that's the middle line that joins the two triangles. We had that in one of our worked examples before. All right. So now we can say that those were the 3 sides we had. and therefore triangle ABC is congruent to triangle ADC. So now you've got to prove that angle ABC is equal to angle ADC. Just ignore the E, it's ADC. So what angle are we looking at? We're looking at B and we're looking at D. You see that? So we could say that because we know that in A that they're congruent and we've proven that, then therefore angle ABC and angle ADC are equal. That's it. That's all, because you've done the hard yards and you've said what congruency proof you use. So you don't need to do any more than just state that because they're congruent, the angles are equal. Okay, so here you said that the triangles are congruent. Oops. And here you're saying the angles are equal. That's what you're saying. It's just going to take a bit of practice, all right? Thank you so much for watching, and make sure you ask your teacher questions because this is a quite a difficult topic. Thank you. Bye.